Keith Parsons, I've been on here before. You can follow me at WLANPros.com, and actually the new website for WLPC Prague is up. It's thewlpc.com. You can go see what's going on there. So let's get started with the association process. And I left this one blank to say, do you really want to know what's going on? Because this can be a complex thing. So here's just a little picture of the little steps that may take place during an association. On the left side, we have the mobile device that moves around, the user's device, and on the right side is the AP that's fixed. And so the APs are usually static and the clients move, and then they have an association process, and it's got a little circle around it, meaning it repeats over and over again. And then once you start down the association process, you could go open or pre-shared key or radius. And then from there, you could go to TKIP or AES, or now I didn't want to get even more complex with WPA3 or OWE. There's a lot of little moving parts in here. Let's try to simplify it a little bit and look at just what I've called for the last 20 years the green diamond. It's the decision takes place at the client. It doesn't take place at the AP, though APs can give some hints and some help, but the client itself is making all the decisions. It's very proprietary. I'm not going to go into the details of this. I just wanted to do this as a review before we got into to look at the data. There's a lot of little pieces going on, and because it's so proprietary, the vendors who use these aren't really forthcoming with telling us how it actually works. Now, Apple's pretty good. They give us some trigger points, so we know that if we can provide the number that they need for RSSI, and then we hit another number, they're going to start looking, and then if they hit another number and there's a differential, they'll make those decisions. Those decisions take place in real time for every client itself. And beacons are going out 10 times a second, and then the clients do a probe, then they get back probe responses, and then they choose. And then after they choose, they go through these next little steps. Maybe 18, 20 years ago, AirMagnet came out with a test tool that would tell you whether or not the authentication request, association request, and their appropriate responses, where it died, at what point in this process. There's a kind of like a 6-way handshake. And what we found after running through thousands, tens of thousands of collections of packet captures, we never once found it died in between authentication and association. It slows down at the decision process, but once the decision's made, it's instantaneous. It moves on and does the rest of the things. So they made a tool that could help us learn where the failure was, and what we learned was there is no failure in the last 4 steps. So how does this algorithm make up the decisions? It uses RSSI, which SSID, SNR, internal lists. Some of them are very sophisticated and say things like, we have an internal GPS and I know you're home and you look like you were on the couch yesterday. So at this time of day, at this location, this was the AP you ought to join because it gave you the best results in the past. There's some very sophisticated algorithms for this. There's also some very simple ones that says, who's loudest? And they just go to whichever's loudest. Our clients all do this differently. So when we are looking to analyze this, we need to understand that the data that's coming back is going to be making these decisions uniquely based on client, even based on driver version. So one of the things I like to say, I've been saying this for well over a decade, is association is to wireless what a link light is to wired. Now, the reason I bring this up is most of us have been hanging around Ethernet for a long time, and we understand that when you put in a link light, you plug in a jack, and you get a link light, it means certain things. It means at layer 1, there is physical connectivity between the device, the port, and the switch is giving enough energy to light up that link light. Now, it doesn't mean everything's perfect. There could be times when you have a bad cable. Most of the time, however, if you get a link light, you don't have a layer 1 or layer 2 problem. If you have a problem, it's probably somewhere else. We use that same terminology here with association. If I have association to a wireless client, how did I get it? It came over wireless. So if I'm associated, that means my wireless is working enough to actually communicate to the AP, choose which AP is best, send some frames back and forth. So I know that the RF is actually working. I get a little frustrated when I go on job sites and people complain and they're like, yeah, the Wi-Fi sucks. I'm like, are you associated? Well, yeah, then the Wi-Fi is working. But it's not going to this website. True, there's a lot of things that could go wrong, but we want to use the association as a trigger to know it's there. So that's just a quick review. Now we're going to get into statistics. Yeah, my master's in business had an emphasis in statistics, and I enjoy statistics. They're pretty nice. So here's just a little backgrounder that the smaller your sample size, the fewer you have, the bigger your margin of error. So the purple line at the bottom, kind of the low flat one, we only had 90 things to choose from. So when we're going to use the data we collected as a predictor, we have a fairly large margin of error. But the more we get a bigger sample size, our margin of error drops. So if people are doing polling for, the next political person, whatever they're going to be polling on, and they come back and they say, plus or minus 3% or plus or minus 10% or whatever, it's based on the size of the sample. So if you go and sample only 100 people, you don't have a very good basis for saying, I feel really strong about it. On the other hand, if you sample a lot of items, then you have even better data. Well, obviously, the most data you could have is 100% sample size, and you go to all of your data, and it has zero margin of error because there's no guessing. We actually counted every one of ours. So this is just kind of a short compilation. If you go over on the left side where it says if the population size is greater than 5,000 and you want all the way to the bottom plus or minus only 3%, we need at least 1,000. In this case, you could look, it's about a 20% capture. So if we capture 20% of our data, we'll have a plus or minus 3%. We'll be really, really accurate. Well, the data we're going to be showing you today comes from 7Signal's been collecting data from their devices basically ever since they started, and has just a wee bit of data. 1 billion. Actually, it's more than 1 billion data points. And better than just 1 billion data points, and to refer back to that statistical slide, we're querying this data against 100%. So the answers we're going to show you, we feel really confident that are pretty strong. We have over 1 billion data points that's going to give us the answers to some questions that I asked. So I had asked Simon at 7Signal to run some queries against this big data set to see how clients are doing. Most of us don't have the data to play with, so now we have some data that we can look at. Some caveats though. This data, even though there's a lot of it, it is not statistically random, because the people who choose to use 7Signal as that gets the data into this data source, they are self-selecting. They're customers who have already chosen to use 7Signal. They obviously care about their Wi-Fi and how it's going. So this is a self-selected set of customers. And of those customers, they're all trying to improve their Wi-Fi. So we're going to get kind of I'm not going to say cream of the crop, because there's a lot of people who do really good on their Wi-Fi, but we're not hitting probably the bottom end of people who just throw up an AP and hope it works. This is also not home user based. This is more enterprise based. Additionally, a lot of this data comes from 7Signal's clients, and their client agents currently don't support iOS devices for a whole wide variety of legal kind of reasons. These data points we have, I was trying to emphasize there, are statistically very significant. Not just plus or minus 2%, they're even tighter than that, but they're not random. So as long as you remember that as we look at the data, let's dive in and see what we've got from a data set. I had to throw this in here just to show correlation does not infer causality. We all know the cat did not cause this carport to collapse. But if you look at it, you can see there's a high amount of correlation. There's a cat at the lowest point of it. It's obviously collapsed. So your brain, and as a human, when we see correlation, we infer causality. That's just what we do. It's kind of how we are. So as I'm going to show you some data sets here, just remember the cat, and that there might be correlations here, and we're not proving that, oh, if you have 7 signal, you'll have wonderful. You know, it might, but the causality isn't direct like that. Okay, first let's look at the clients. Yeah, Jim, any comment on this overwhelmingly predominant number here?
Yeah, you know, this is a reflection of what most enterprises devices that are capable of running third-party software, at least, look like. Windows is still very dominant in the enterprise. I actually thought there'd be more Mac OS because it's really grown in enterprise support in the last few years. But yeah,
but
Windows.
This is cumulative data, so it also has been being collected for years. And I think, like you, Mac OS is up and coming, but not the predominant at all. And it's pretty obvious, which also tells you when you look at this is we better be sure we take care of those Windows users. I know you're a Mac user, I'm a Mac user.
Yep.
I like Macs for a lot of reasons, especially when it comes to Wi-Fi, but our customers are predominantly in the Windows world, so we have to be able to take care of them. And luckily, 7 Signal's agents run on Windows as well. That also might be part of the reason this is a little skewed, is that there's a lot more customers with Windows problems. Haha. I knew I'd get that in there somewhere. And so they show up. So top 10 client adapters. Sorry, it is a little small. On the left side, you can see it's almost 50-50 AX versus AC, which is a little shocking to me. I would have assumed AC would have been a little lower. And then you can see on the right side the list of the drivers. Well, this also supports that we have a lot of data that's coming from the Windows users. And so the Windows drivers would be predominant. That's just, yeah, duh. We have lots of ones. So then when you look at the drivers, so you can see here that there's a lot of drivers that we can look at and play with. And we haven't went into the detail, though we could. And in a future webinar, we might actually make the queries to the data set to find out which of these drivers is the worst, which is the best, those kind of questions. Today's set was more on, let's just take a look and see what data we have. But I bet in the future, if we do some qualitative instead of just quantitative answers, we might be able to help people take some data back to their bosses and go, we really need to get off this driver. We need to move this driver, and here's some supporting reasons. Now, here's another one. This is by phi. This is ABGN. And those two little teeny weeny little tiny, I have to put my glasses on, I can't even see the slivers. Those tiny, tiny little slivers for the B and the A, yeah, you can ignore them in your networks, as you should ignore them. I've been trying to get my customers to get off of B and A support for a very long time. You also can see the G is also just a tiny sliver there. It's been many years, over a decade since those came around. So I think we should finally get off of those. There are so many things that can speed up your network by just getting rid of the legacy data rates. I still, just last year, had an edu client that said we have to support B rates. And the answer was they were a state university and they had to support anything that anyone brought in. And so my answer was, do you allow people to turn in their homework made with a crayon? And of course they laughed and they said, what do you mean crayon? I said, well, the last time today's freshmen were using crayons, that was the last time 811G was around. And they're like, oh, okay, well, maybe we don't need to let them do something so old. And we went to the provost of the management side of the university and said, did you really mean we have to go that far back? And when we explained it in those terms, they went, well, not really. I mean, who has stuff that old? So here we have some data you can now take and support and say, yeah, look, we're way ahead of the game. N is still just a sliver. Now it's a substantial sliver. I wouldn't want to have to fix N problems, but we still need to support N. But AC is obviously the way to go.
Yeah, what's interesting here too, Keith, is you know, looking at that last slide, we're about 50-50 AC and AX in terms of the PHY that clients support, but the connections they're making in our customers' networks are predominantly AC. So
hold on for the next slide.
okay.
Nice segue there. Thanks, Jim. Oh, sorry. It's coming up. There's another slide that addresses that specifically. Though that they're 50-50, these are, you're right, the connections are coming in this way. And that would be dependent on their infrastructure that they have. We do have some numbers when we get to MCS. We'll see some differences in the AX. So moving on to the next set, let's talk about the radio frequencies. We have 2.4 gig frequencies that's used by Bluetooth, BLE, 15.4. We have 5 gig frequencies for N, AX, and AC. We have 6 gig frequencies for AX, the Wi-Fi 6E stuff. And if I just zoomed in on this to look at the details, if you want to zoom in on yours when you look at the copy, when you look at the slides, I've added some details in the kind of almost the middle of the page here. There's a bold 5, and this is an older one. We've updated it since then. We have something called the PSCs, the preferred scanning channels, and that's the 5, 21, 20, 37. They're actually, this is an older one that I used. They're actually now every 4, and the updated 6 gig shows those. But I also just want to let you see there's a free space path loss at 1 meter, and you can see how that changes. You can see the actual center frequencies change. At the top, there is the physical size of these, and so the chart has a lot of detail on it. But let's now take the topic is frequencies and see how we're broken down. Yeah, this is why I gave the caveat up front. Your data set is about people who care about their Wi-Fi, and so they've focused on 5 gig.
Yeah.
I've been to countries where this is flipped depending on the country. This is a very North American picture, and it's also enterprises. I like it. It's not that I don't like how this is headed. This is a good direction.
And there is some work from home data in here too, from people taking their work laptops home and Mobileye collecting data on their home networks too. So, and that's where I expected to see, more 2.4 gigahertz. So, but this is a lovely chart. I'd like to see 2.4, even smaller, maybe even 0. It also makes the case that, your enterprise SSIDs should really just be 5 gigahertz only, unless you really must do something with 2.4.
EduRoam.
Right.
Anders is on the call, so I like the idea of having a 5 gig only EduRoam. I don't know if
me too.
Anders, send me a DM on the backside if that's even possible. I think that's legal within your EduRoam world to have a 5 only. I know you can't have 2 different ones. You can only have 1, but if we dedicate 1. So maybe by the end of the call, we'll get a DM or a chat from Anders to tell us the answer to that question. So predominantly 5 gig, big answer there. Next topic that we're going to look at some data is about the MCS process. Now, what happens is the transmitter, it could be the AP, it could be the client, which whoever's going to transmit at the next transmit opportunity, they're going to decide how they build their frame. So the upper layers bring down, all the way down to the IP layer tells the MAC layer, and the MAC layer tells the PHY layer, go send this stream of bits. Well, right at the end, right before it makes that decision, it's going to choose which modulation technique. BPSK, QPSK, 16 QAM, 64 QAM, 256 QAM, maybe even 1024 QAM. It has a coding scheme that's going to choose, and it's going to choose channel width, it'll choose guard interval, it's going to make a decision on spatial streams and transmit power. All of these issues are decided by the transmitter. Obviously, the transmitter isn't a human, it's an algorithm. And so the manufacturers of the chipsets and the software, the firmware that sits around the chipset will use data that it's collected from its previous attempts to choose the best MCS it can. The reason I love MCS as a data piece is it's self-reporting. Whoever's going to be doing the transmission, I'll drop in the word client in here because this is a client webinar, but the APs do the same thing. The client's going to decide, how do I most effectively send this set of data? Now, I don't want it to die, because if I pick the wrong MCS, I put these pieces together, I send it off, I don't get an ACK, now I have to make a decision. Which of the things that I just chose was the reason it failed? Did it fail because I was in the wrong channel width? Now, if you go too wide of a channel, you also increase your noise floor, which lowers your SNR, which may have been the reason the modulation failed. But the client doesn't know that. All it knows is I attempted and it didn't work. So sometimes they're programmed to go, well, try it again. Maybe it was busy. So just because there was a failure doesn't mean it was my failure. It could have been the failure systemic in the environment because there's too much traffic. So I'm going to try the same modulation again. Some of them might count 2, 3, 4, 5, and if it still fails, then they come back and say, okay, it probably wasn't super, super busy because I tried it 5 different time slices and none of them worked. Now let's try changing the modulation. Maybe I'm going to go from a 64 QAM to a 16 QAM, allowing the system to have more robustness, and maybe that will get around the problem. I might change coding scheme, I might change guard interval. There's a lot of things that could change, and the algorithms that use this have been explicitly designed to meet some goal of whatever the vendor wanted their system to act like. They might say, if I can maintain 2 spatial streams, drop my modulation as long as I can keep that 2 spatial streams. But if I can't demodulate the spatial streams, then anyway, there's a whole bunch of options. Why this is self-reporting is that every transmitter tries its best, and if it fails and it downgrades to a different modulation, a different coding scheme, any of these changes, we will see that reflected back in the MCS rate. So if a client is having a difficult time, it will downgrade itself based on a problem with the RF. This isn't a problem with DNS or DHCP or some other thing that could be on the network. These problems are our problems. They're right here in the like hardcore RF right in the center. So MCS is when you're going to be making one of these choices, and we'd like to go as fast as possible. And if we can, we'll maintain that. If we can't, we'll drop. So I just zoomed in here so you'd have a copy of the bigger piece here, and bring up one data point. Actually, so I can stop talking and let Jim have a piece in here. Jim, how do you get MCS on your Windows clients?
Good question, Keith. So the MCS index, right? In order to know exactly where you are, you need to have the guard interval, the channel width, the data rate, the modulation, all the ingredients. And in Windows, you can only get some of those, and particularly the guard interval you can't get. So at 7Signal, we've developed a custom algorithm called 7MCS that reverse engineers that as best we can using the data we have available. So in Windows and in some versions of Android where we can't get MCS, we reverse engineer it for our customers.
Which leads, and this is another caveat, we're going to show a slide in a minute that has an MCS of 8.5. Jim, how do you get 8.5 MCS?
Yeah, so that's the challenge. If you don't have the full data set, in some cases there's ambiguity. So if this is a good slide to talk about this, because if you look at one spatial stream, MCS 6 and 7, the resulting data rate is identical across there. You've got 65 megabits per second for 6 and 7. So what do? You don't know exactly what it is without knowing the guard interval. So that's where 7MCS says, right, we'll call this 6.5. We know it's either 6 or 7. We don't know which one. We still want to tell you something really valuable, that you're using an MCS value that's, pretty high up there. And so that's where you see a 6.5 or an 8.5 in 7MCS.
So nothing wrong, just supporting what you're saying. Nothing wrong with showing an 8.5. We just wanted to warn the listeners when they see the next chart what that the 0.5 means. It's in between there, and because the drivers aren't giving the exact MCS and you reverse engineered it, it gets us really close. But at least you know it's not anything else. It's up in that range. So here we go. This is a very simple one. MCS by frequency. This is comparing 2.4 to 5 gig. And obviously, we get a lot better and more. And this chart is also reinforcing there's a lot more data showing 5 gig than there is 2.4. But the 2.4 is also reporting a lower MCS. Even though it's smaller because the data set we have less 2.4, it's predominantly 7 by a long shot, which means the clients that are connected to sites that are using 7 signal, even in the 2.4, they're doing very healthy. They're not like down on the bottom. So this was a very helpful chart. It made me feel good that even if you're in 2.4, you're doing pretty good.
And 7's as high as you can go with 802.11n in one spatial stream. And 7 MCS, by the way, normalizes 802.11n, or it doesn't normalize it, adjusts it. So it's reported as just 0 through 7, like it
doesn't take like a 15. It just reports it back in the normal 7 categories.
So I think this is clients using those 2.4 gigahertz radios that are stuck in 802.11n land until you get to AX, and using the best MCS they have.
Yeah,
so it's nice to see.
And those in 5 gig are up there in the between. I mean, if you add it up, the 8, 8.5, and 9, these clients are really, really happy. This makes my heart warm and fuzzy. This means clients are super, super happy. Back to the original caveats. Is that because 7 signal made them better, or because the customers who cared about their Wi-Fi use 7 signal? So I can't say there's causality here, but there's definitely a very, very high correlation. This is a very, very happy thing. Now, those who are down in the 4, 5, I am not really. Those are ones that tell me there's an RF problem. Just my own personal thing. When I look back here, if I see anything that's a 3 or a 4, that's a 16 QAM. They are definitely having RF issues. This is not some DNS issue, some network issue. This is straight up RF. A 0, 1, 2, 3, huge RF issues. If it's a 4, up to 4. If it's a 5 or 6 or a 7, I'm still not terribly happy. They're having some issues. If they're capable of doing 8 and 9, and they're in a 5, 6, 7, they had some issues to get there. If the only thing they could get was up, the fastest they could get was a 7, then I'm happy with the 7. So it's that up through 4. If I see anything in there, I am all over that. That is an RF issue. We need to go and fix something's wrong with our network. The 5, 6, 7, I may use that as a trigger point to tell me something's wrong. So with the data that we're seeing here, there is some 4, 5, 6s, and 7s, even in the 5 gig, that would make me want to go and do some further analysis to see how to fix it. But by and large, this data set showing these are really, really happy customers.
There's one thing I noticed in that chart too that's kind of interesting. There really looks like there's significant bumps, maybe not statistically significant, but they catch my eye at MCS 7 and MCS 4. And those, MCS 7 is where we drop down from 256 QAM to 64 QAM. And MCS 4, like Keith mentioned, is where we drop down from 64 QAM to 16 QAM. So, they're either, once they get to the next level of modulation, they need a lot more SNR or whatever it is they need to decide to jump up to the next modulation scheme, or they're going down to the lower modulation scheme faster and staying there faster. But I just thought that was interesting.
And I've seen some client drivers who are sticky at those locations because it's the fastest 16 QAM is way more robust than the slowest 64 QAM. So
Right.
those little humps kind of make sense. Let's look at by PHY, and yeah, it just tracks same kind of data, same information. We just ask the data to sort a different way, and yeah, if you're in 5 gig and you're running AC, you're just like going, yes, life is great. Here's where we had, and this I just put a caveat. Earlier we'd had over 1 billion data points. For AX clients, they're newer, and our data set is only 63,000. Now I say that as, oh no, only 63,000 compared to 1 billion. It's 63,000, and this is 100%. So this isn't a sample. This is of 100% of all the AX we've seen. This is what they're reporting, and again, I'm shocked. That is a huge number out there to be at MCS 11.
Yeah.
I wish I could get my house to be that good. That's a very, very good number. And you see the humps as well. The 10, we're getting better results with 11. We're getting better results with 9. We're getting better results with 7. So in the MCS pairs on the modulation, they're staying on the high side, not on the low side of those MCS pairs. So impressive data. What are your thoughts?
Yeah, and this chart is representative of our customers' AX clients only when they're connected to AX APs. In other words, they have an AX connection, which actually is less common. We saw, how AC connections are super common, even with a 50-50 client mix, because customers are just having trouble getting AX APs, supply chain woes, and not upgrading as fast. But I think one of the interesting stories here is that we all kind of scoffed at 1024 QAM with AX. No way that can work. The EVM is so small.
I know I did. Yeah.
And looks like it's working. There's better radios, better filters, better amps, better transmitters, and better receivers that are resulting in 1024 QAM. Maybe 4K QAM is within the realm of possibility with Wi-Fi 7. So we'll see.
We'll see that, but this shocked me. It impressed me when I looked at the data, and I'm like, I love having data because then it's not just me feeling a certain way. I felt like the 1024 QAM wasn't going to be as successful in my own tests, and I've just done. Getting X clients and XAPs is pretty tough. You have to be really close, and things had to be just right. But the data is pretty irrefutable that when it works really, really well. So it gives me hope for the future of AX. I'm not sure if all the other AX things are actually panning out, but that's for another webinar. We'll query the data maybe 6 months from now, and there's more AX data to look at and see if we're seeing more OFDMA as a ratio to OFDM without. Is MU MIMO both upstream and downstream? All the extra little pieces are there, but this is a good starting point to look forward. We also looked at the data based on whose chipsets, Intel's Core WLAN or Realtek. I'm guessing most of the Realteks are Linux people. The Core WLANs are from the Mac OS, and the Windows are there. And again, pretty predominant. You can see that they're hunkering over on the right side where they should be across the board. Not so happy with Realtek. Now, I'm not sure why. Do you have any idea why the Realtek might be a little less successful?
Yeah, and I think the Realtek client mix is mostly Windows, probably some Linux there too. But issues with roaming there, resulting in poor SNR and MCS shifting to compensate. So they're not the only vendor
Yeah,
that has roaming issues. I don't think I've seen a single Wi-Fi chip maker that hasn't had
some
problems with
issues. Yeah,
that, but something we see um, more
and
often
though
than we'd
this
like to
these
with
are
Realtek adapters.
these are the same customers, so it's already skewed a little bit to people who are caring and they're trying to fix their Wi-Fi. But this means Realtek itself is having a little more difficult time because it's the same environment, and this is comparing their actual chipsets. And so, just a data point to throw into your mix and think about. Here is the same information just distributed by phi, and again the AX is way up there. Even the AC and the N, they're all doing really, really well. So the data that we've seen is people are using Wi-Fi and they're getting really good results. And when they're not getting good results, we see them drop down a little bit. But the statistician in me is like, this is good stuff. This is showing that when you care about your Wi-Fi and you tune it properly, you can get your clients to be self-reporting with their MCS as basically as good as they can get. Yeah, we could lose some of the sixes and sevens down there, but very impressed data. Any final comments there, Jim?
Yeah, I think, if you look at this again, thinking about, modulation schemes, I think, seeing data like this might be what motivates the standards bodies to say, let's keep going. And it's not just, necessarily being able to advertise faster data rates because of these new modulation schemes, but the fact that perhaps, they see the same data that says 64 QAM, no problem with 802.11n, 256 QAM. The AC hardware out there is doing great. 1024 QAM doing great. Let's keep going. Let's go and go and go until, wherever that limit happens to be in terms of, the fastest modulation we can support in real world environments.
And what it tells me is it's working. The things we're doing, we're making our networks better. So key takeaways here. If you're not a 7-signal user, obviously you're watching this webinar, you could contact them and see about a POC. But even without 7-signal, you can get the same data yourself. You can go and grab what's your ratios from your controllers of B, A, G, N, and show your management the hard data of what you need to work on. You can get average MCS rates across your clients, across your locations, and find out if you're not achieving these levels in your sites. Use this information, this technique to find out why. Why are you not maintaining MCSs the higher 7, 8s, 9s, 10, 11 if you're running AX? So use the data that we have here. It's a billion data points. If you have a question, contact myself or Jim or anyone at 7-signal and say, I'd like to ask this query. The data is there. Let's see if we can use the data to help the entire industry come up with better metrics or use the metrics we have to be able to design and engineer and tune our networks to be better. And with that, let's see if we can answer any questions if people have hung in this whole time.
All right, thanks,
Sorry,
Keith.
I didn't look at any questions. I was like looking at my screen. So
yeah, no problem. We've
can,
got a couple good questions here. We'll tackle before we transition, and thanks for presenting that data for us. So Fang starts us off. And I think we talked about this a little bit, but why 50% 11AX adapters, but 87% use AC rates? And we just talked about the fact that they're operating in AC networks where they have to operate in AC mode in that case. And so,
or it could be that they chose the AC rates on an AX system because they were getting better results. We haven't had enough AX client data to show that they prefer AX to AX or do they prefer AC if it's a stable AC. So again, we only have 63,000 out of a billion. We don't have enough data to know, but you're right. They are choosing to go AC. Could be because of the infrastructure. It could be because themselves. We just don't know the answer to that yet. But very good question.
And the other thing you see, and I'd like to hear your thoughts on this, Keith, is a lot of early adopters of AX in terms of deploying AX APs got burned by driver issues and turned off 802.11ax on their AX APs. So they, to a client, they're an AC AP. Is that still, do you still see
Not,
that a lot?
I still see customers who are making that decision for a wide variety of reasons. I don't know if it's because the early adopters were too new. I mean, if you're going to go out today and buy a AP, why would you buy old chipsets? I mean, it's just silly. You want as long as you can. But we also have supply chain issues, and sometimes people can get the newer stuff rather than the slightly older stuff. Supply chains are weird. And so people might have put in an AX new, like in one floor of a building, but the entire rest of the building is AC. To make it stable, they might downgrade it, not because it didn't work, but because they wanted stability in their network.
Yeah, yeah, fair enough. Question here from Nick. Thanks for the question, Nick. He says, any data on performance for different driver versions from the same vendor? And that is something that Mobileye does for our customers, but we haven't queried the data to come up with any global data on that, any analysis on that across customers. But if you're a Mobileye customer, you can see. And this is an interesting question from Fang. I don't know the answer to this when we're thinking about the MCS that we're getting from clients, but he says, do the MCS samples include those packets transmitted in errors? I'm not sure.
As in, I sent a packet at MCS 7, it failed. I downgraded to MCS 5. Did you count the one that was a 7 as part of the number? Yeah. I don't know how your capture tool keeps those, or if because it didn't get an ACK, it tossed it out.
Yeah, I think I want to say with Mobileye, we're probably not getting those failed MCS rates because the client's going to shift so quickly that by the time we query the operating system for all the data we need to figure out the MCS, it's probably, stabilized at that point. Interesting question. So maybe one more question here from Mark, who says, I have a few Realtek 802.11ac cards with the latest drivers that keeps trying to attach to much further APs. What should I look at? Low data rates are already disabled. So any tips there, Keith?
I would first, and this is going to sound silly, I would split my SSIDs into whichever thing first between 2, 4, and 5 gig. But you could also make a sample of having an SSID that's only for your faraways and an SSID that's only for your close. And then you're in control of that decision a little more. Sometimes you have no control over what the driver's doing in its decision process other than you can fix the SSID. So if you can fix your SSID for the near versus far, split those, and then see, does it, when you force it to be only on the near ones, does it maintain a better MCS? And then change the SSID decision to go to the far one and see how that works. Then that might give you enough information based on that to say, yeah, I need to do something different in the network. We don't have good view into what those roaming algorithms are from any vendor. Even when they say we do this and this, yeah, I've seen they do other things as well. So the best I found is just run a lot of tests, hold all things constant, basic scientific method, walk on one thing and try it, and then change, do it again. It's not an easy thing, well, it is a fairly easy thing. It just takes a lot of time. And when you're done, you have this kind of murky idea. I think it kind of does this, is all you're going to get. Sorry.
Yeah. Maybe a couple other considerations. This comes from Anders in the chat, but just make sure those nearby APs are operating on channels that are supported by those clients. Maybe they're using a weird DFS channel they don't support. And check, make sure that those the RSSI from those distant APs isn't, too loud. And that's, of course, subjective, but one of the things some clients will do, I don't know if Realtek does this, but some clients, like Keith mentioned earlier, will just look for a loud signal, and they might just find the first signal that's above the threshold they want to attach to an AP. Just happens to be that AP that's further away, but it's above neg 70 or whatever, so it associates, even though there's one right here at neg 50, right?
And it feels random, and it kind of is. It's just who was the first to answer. And if we go back in the Wayback Machine, there was a time when clients chose APs based on how fast they responded to a probe, thinking, well, if you responded quicker, you must be closer. There's a lot of silly things they've done in the past. So I wish we knew what was going on inside there. Part of me wishes the 802 committee would actually lock and say, this is how we're going to do it. And then we can design our networks to maximize that. And the other side says, well, I kind of like some are better than others. I just don't like the fact that we don't know.
Yeah. Yeah. It's really a challenge. And like you said, you just have to set up a lot of different tests to get a murky idea of what the association algorithm really is. So, all right. Thanks, Keith.
Get, the closer the less murky it gets, the more data you have.
Mm-hmm.
But I just wanted to thank Simon and the 7 Signal team. The data that you collected is statistically significant. It has some caveats about what you have, but it has actually been very helpful to see that data.
Yeah, it's been really fun to run some queries on it and start to see what we can find out. So thanks for sharing that, Keith. And Heather, I think we're ready to transition.
All right. Yes. Thanks again, Keith. Lots of great comments in the chat. Really great session. So thank you, as always, for being with us today. And Eric, you can come out of hiding. Oh, geez. He's in a dark corner. He really is in hiding, huh?
There we go. Is that a little bit better?
Yes. Yes.
All right. It's using the wrong camera. So yeah, let's try this again, shall we? Use the 4K.
There we go.
Oh yeah, that's much better. Less scary.
Mm-hmm. All right. Well, good stuff, guys. And thank you for inviting me to be here for this week's episode of 7 Minutes with 7 Signal. This is where we take a little feature inside 7 Signal. We unpack it and kind of show you how it can have significant value. I'm going to share my screen with you here. And it's such a wonderful opportunity to have Keith Parsons with us today to show us some of this data that we get on a large scale. I'm going to show it to you now on a small scale inside 7 Signal for these few minutes here. So you guys hopefully should be able to see that right about now. Tell me if you can, give me the thumbs up. All right. Okay, so first of all, guys, I just want to show you what a roaming issue looks like in 7 Signal when we have Mobileye installed on all these devices. This is just a very rudimentary example, but I do want to show this to you. This is a device that I'm looking at here, and every few minutes we're checking the connected signal strength. So in this case, 74. And because we're looking at the scan data provided by the operating system, we're also able to see the neighboring access points and their signal strength all around. This is a very nice extreme example of where this is an access point, or this is a client connected at -74. Clearly, there's a better option at -52 right over their head. However, it's their device that is, for some reason, decided to stick and not roam. Oh my, and look at this. It's a Realtek adapter right here, as we can see in the corner, because we're gathering that configuration information right from the device. So this is on a one device level. Let's kind of take more of a macro look at this now. So I'm just going to back up a few screens. And let's back up one more. one of these cool reports that you can run inside Mobileye is exactly what we've been talking about. Hey, give me a list of all of the adapter driver combinations that are in my population that I have out there. And this is a customer that's got a Mobileye on about 3,000 or 4,000 devices. So they've got a nice little sample set. And you can see, for example, these are the same adapter right here, different drivers, and we're measuring the performance. Okay, so you can see how different drivers may be performing differently. And I'm looking at a 5-day period of time here. The other thing I want to say is this. Okay, so I can see how many clients are actually experiencing these problems. So for example, if you were to take 17,000 divided by 970, that's going to be about 17 roaming issues that we caught per device over the time period here. Now, if I go down here and look at the real-time conductor, okay, and if I were to do the same math, this is approximately 38, 39 roaming issues per device for the time period that I've selected here. So it's really nice to be able to see, okay, let's stack. There is so much variation in our environments, we don't even realize it until we run a report like this and we can see, whoa, I mean, we don't have a homogeneous environment at all. So that's really nice to be able to see. Now, I want to take you one layer deeper. And so what we're going to do is we're going to look at a device and its performance, because as we know, I mean, we can't see what's going on in the environment with a device, but 7Signal can. Let me show you an example. So this is a client device. And if you look right here, okay, they're on 5 gigahertz. Then they roamed on over to 2.4, good MCS score, good signal strength. If you look at the right side of your screen at -59, -60. And then look what happened. They moved around a little bit and they roamed back to 5 gigahertz. Whoa, look at that. And look at their signal strength. Look how their MCS score just hit the floor, hit the basement. And then lo and behold, the device is like, whoa, wait a minute here. I'm not sure I like this. Maybe I should roam on back to 5 gigahertz. And it does. Nice signal strength, good MCS score, decent data rate. And then lo and behold, it goes back to 5 gigahertz. And you can see how it's just kind of going back and forth depending upon the situation. This type of device behavior would be invisible to you otherwise. And so it's just nice to be able to follow the path, if you will. And again, I can click and I can drill in, and not only am I going to get, okay, what the best neighboring signal strength is and all of that and where was, but also I've got this nice little roaming history where I can see the name of the access point that I was connected to at the time that it decided to then roam to one, roam to the other. So really powerful, guys, when you've got this kind of detail. If you're a statistical genius like Keith Parsons is, then you can take this data, you can download it, you can put it into spreadsheets, you can do pivot tables, and you can really learn a lot about your design as well as about your device population and how it interacts with that design. So that's what I want to share with you guys today. Thanks for having me. And I just wanted to remind you all that, you know, you and me, we can't see or hear Wi-Fi, but 7Signal can. Thanks, everybody. Have a great one.
Awesome. Thanks so much, Eric. Thanks again, Keith, Jim, for joining us. And of course, thanks to all of you. We wouldn't be here without you. So we will see you back again, same time, same place, and have a great rest of your week and weekend.
Thanks.